So, again, on here, this is the first half sheet of the review. Again, I'll post all these answers up online. But on this first one, we have the figure that we have is a trapezoid. The properties that we need to know in order to solve this one is the fact that we have a mid-segment. We know we have a mid-segment because the congruency markings on here tells us that E is a midpoint and F is a midpoint for each of those sides. Since those are midpoints, this has to be a mid-segment. Which again, a mid-segment for a trapezoid can also be called a median of a trapezoid. In Springboard, they use the word median. But again, a lot of other books just call it a mid-segment. Same with the mid-segment in a triangle. All right? Now, on here, the mid-segment of a trapezoid is the average of your two bases. So our two bases here are 16. So we have 16 plus 3x plus 11 divided by 2. That gives us the average, which has to be equal to that mid-segment of 2x. Now, we can go ahead and combine like terms. We got 3x plus 27 over 2 equals 2x. If both of these values were evens, I'd probably just go ahead and divide by 2. But since they're odd numbers, I don't want to deal with decimals. So instead of dealing with the decimals, I'm going to take the 2 and move it over to the other side by multiplying it to the opposite side. Because again, in order to move something across the equal sign, you do the opposite operation. So we multiply both sides by 2. We get 3x plus 27 equals 4x. Then bring the 3 across by subtracting it. And you'd get just 1x or just x equals 27. That's not the answer they want, though. They want you to find the length of EF. So we have to take it and plug it back in. So EF is going to be equal to 2 times 27, which is 54. And it said the measurements are in centimeters, so this is 54 centimeters. Now, on number 2, guys, figure JKLM is a trapezoid. What is the value of x? Well, if this is a trapezoid, all we know from that is that these two lines that are our bases are parallel. And a trapezoid, any trapezoid, doesn't mean that it has to be an isosceles trapezoid. Any trapezoid, the interior consecutive angles or the same side interior angles are supplementary. Right? That goes back to our idea from parallel lines. So this one and this one, these are same side interior or consecutive interior, so they have to add up to 180. So 5x minus 4 plus 39 equals 180. Negative 4 and 39 gives us positive 35. Subtract off the 35. And that leaves us with 145. And then 145 divided by 5 gives us 29. And that's what they want us to solve for was x. So that's the final answer. On number 3, what is the perimeter of the square below? In a square, all sides are congruent. So it doesn't matter which two of these we set equal. Not for this one. So I picked the two that would look like they're the easiest, so the smallest numbers. So I'm going to use these two. So I'm going to do 2x plus 9 equals 3x minus 2. Bring the 2x over. I'm left with just 1x. Bring this 2 over to the other side by adding it. We get 11. So x is 11. Once we know what x is, we got to plug it back in. Does it matter which one you plug into? They all give you the same thing. So I think the easiest one would actually be this one. So 3 times 11 minus 2, that's 33 minus 2, which is 31. That's every single side. Because every single one of these sides is congruent. They want the perimeter. So we have 31. You could add it up 4 times, or you could just say 31 times 4, which is probably a little bit faster. Because again, we have 4 sides that are all 31. It's going to give us a total of 124. And that'll be... Oh, no, that one didn't say centimeters anywhere. I lied. You don't have to put centimeters. Just 124. On number 4. In rectangle, MONE, measure of MEY is 17. Measure angle YEN is 4x minus 7. Those two together, since this is a rectangle, equal 90 degrees. Again, be careful. One of the common mistakes here would be to say, oh, those have to equal each other. They don't have to equal each other. The diagonal in a rectangle does not bisect. So, 17 plus 4x minus 7 equals 90. Add the 17 and 7, you get 10. Whoops, I started to go to the next step. Subtract the 10, you'd have 80. Divide by 4, and you get 20. X is 20. On number 5, all measurements are in centimeters. What is the length of EF? This one's almost exactly like the first one. You have to average the bases. So 4x plus 27 plus 15 divided by 2 equals 5x. 27 and 15, if you add those two together, you would get 42. Now, you have an option. Currently, both of those numbers are evens. So, since they're even numbers, you could divide both of them by 2 to reduce, or you could choose to just multiply the 2 to the other side, like we did on problem 1. Again, I'm going to do this the other way. Since they're even, I'm going to go ahead and just reduce these. This would be 2x plus 21 equals 5x. You can bring the 2x to the other side by subtracting it. Gives you 3x. Divide by 3. And x is 7. Again, that's not the final answer. You still have to plug it in. So for EF, you have 5 times 7, which is 35. And again, this said it was in centimeters. That was the first part of the review. Huh? Any other questions? 5 was 35, yes. Any other questions on this one before I move on to the main review? All right. So now, on the next one, for number 1, it says in the figure below, if the figure below is a parallelogram, which statement is not necessarily true? So it being a parallelogram, the one thing that tells us by definition is that these sides are parallel. So I'm going to go ahead and mark those. Now, for each one of these, I'm going to use a different color to help us determine, is this something that would work? So, first, for A, angle MKA. MKA, that's this angle here, is congruent to KAR, this angle here. Those would be alternate interior angles between those two parallel lines. So that would be a true statement. Again, alternate interior angles are congruent. On the next one, KS and SA. Those two should also be congruent because in a parallelogram, the diagonals bisect each other. So that is also a true statement. If we go to D, D says MK is congruent to AR. Actually, let me go ahead and use 2 lines there since we already had one marked with 1. So this is saying opposite sides are congruent. That's also a property for a parallelogram. So that one's also true. So C must be the one that's wrong. Let's see what it says. For C, it says MS and KS are congruent. Do these two have to be congruent? No. This is the one that's incorrect. Because in order for those to be congruent, that's not telling you that the shape is a parallelogram. What shape would you have to have in order for these two to be congruent?
Oh, a triangle like that.
No, not. What type of hold on. Shh. What type of quadrilateral would this be if those two were congruent?
Rectangle.
A rectangle. In a rectangle, shh, guys, I'm getting too loud. Again, I'm recording too. Now, in a rectangle, the diagonals are congruent. In a parallelogram, diagonals bisect each other. So, for a rectangle, you'd have all 4 parts be congruent. Again, since it just says parallelogram, this doesn't work. All 4 of these little ones would be congruent in a rectangle because, again, the diagonals of any parallelogram bisect each other, but the diagonals of a rectangle are congruent. So if you have 2 congruent diagonals that are being bisected, all 4 small pieces would be congruent in a rectangle. All right, number 2. See you. What are the values of X, Y, and Z? Now, again, this is a parallelogram. All we need to use on this one, we have angles labeled. We don't have anything else. We don't need to worry about any other parts of this. So, on this one, again, focus on what you know about angles. There's only a couple of relationships you know about angles in a parallelogram. For a parallelogram, opposite angles must be congruent, and consecutive angles must be supplementary. Those are the only 2 properties you're using here. So, these 2 angles must be congruent. These 2 angles must be congruent. And then any combination of what I just did in green and red would be consecutive angles. So they would have to be supplementary. So we know that the 142 is also the measure of angle Y. For X and Z, we'd have to subtract 180 minus 142, and we get 38. So that would be our measure for the other 2 angles. On these, the degree symbol is next to the variable, so you technically don't have to put it on there. On 3, what is the value of B in the parallelogram below? Now, it only says this is a parallelogram. There is, I can't remember if it's on the review or on, yeah. So this question, number 3, is different than what they give you on 23, on the back. This one says parallelogram. 23 says square and gives you the same type of information. For a parallelogram, we only know that the opposite sides are congruent. All right? So those 2 and those 2. So for this one, we can only set these 2 equal to each other. Those are the only 2 that would work for saying anything equal. You cannot use the 3b to solve on this one. Whoops, I somehow just made that 11. So that should have been 1, not 11. Equals 3b plus 15. So, bring the 3b over by subtracting, you'd have 2b. Bring the 1 over by subtracting, you'd have 14. Divide by 2, and you'd have 7. So, B is 7. For number 4, for what value of Y is the figure below a parallelogram? So, these were all supposed to be Y's, but this one really doesn't matter anyway because Oh, can't see it? Let me move it up. On this one, these two are the two that should be congruent, right? This one is only congruent with this side. So again, that one doesn't matter. We're just using the two that are being bisected here. So 5y plus 3 equals 7y minus 9. Subtract the 5y, you get 2y. Add the 9, you get 12. Divide by 2, you get 6. Now notice, everything that we have done up to this point required the knowledge of those properties. Could we have done any of the work if we didn't know those properties?
What?
No. Again, I can't stress that enough. Those properties I showed at the beginning of tutoring, the ones I posted on the tutoring site, make sure you go back over and study all those properties. You have to know them in order to do any of this. All right. Now, the next ones are specific to the properties. It's not even doing any algebra. It's just, you got to know your properties. For what quadrilaterals are the diagonals always congruent?
Rectangle and square.
All right. We got rectangles.
And square.
We got squares. And there's one more. Say it again. Isosceles trapezoid. So, you mean trapezoid? Yeah. No, that's all right. For an isosceles trapezoid, this is what it looks like. Shh. Right? But these two sides are parallel. If you drew in your diagonals, these two diagonals are congruent. Right? Now, what's different about this, the diagonals in a trapezoid compared to the diagonals in a rectangle, the diagonals here are congruent, but they're not going to bisect each other. Right? These will never bisect each other. So again, they are congruent, but they don't bisect. Now, so like if you were just told a figure was a quadrilateral with congruent diagonals, you could either identify it as a rectangle or an isosceles trapezoid. If you knew that they bisected, then it's specifically a rectangle. And that goes back to, you guys remember the keyboard question in the Springboard book?
Oh yeah, I remember that one. Right. It was one of the other night.
Again, it was all about the diagonal. Springboard just listed the idea of a rectangle. But again, isosceles trapezoid could also explain that one as well. All right, let's go on to number 6. For what quadrilaterals are diagonals always perpendicular? All right, rhombus, kite, there's one more. And again, you can say rhombuses or rhombi. Either one's correct. And then you said kite. There's one other one. If you have rhombus, square. Yeah. Because again, square is always a rhombus. So rhombi, squares, and kites all have perpendicular diagonals. For, say again? A square is always a rectangle. A square is always a rhombus. A rectangle or a rhombus is not always a square. Yeah, by definition, a square is both a rectangle and a rhombus. All right. So now, on number 7, if the figure below is a parallelogram, which statement is not necessarily true? So, again, going through these, for A, MAK, this angle here, and AKR, those again are alternate interior angles. Those would have to be congruent. For B, MA is congruent to KR. Those are opposite sides. Those are always going to be congruent. So that also works. For MS and SR, those will always be congruent because diagonals bisect. Again, these two, SA and SR, those do not need to be congruent. That's incorrect. That's the one that doesn't work. Again, because it's not saying a rectangle. If it said rectangle, that would be true. Parallelogram does not have to be true. On 8, and some of these are very similar to the first column. Again, just extra practice. You'll probably see questions like some of these on the test. Shh, guys. So again, on here, opposite angles, congruent. Those two and those two, congruent. So we got Y has to be 128. The other two, subtract one of them from 180, which leaves you with 52, and that'll be the other two angle measures. On 9, again, in a parallelogram, we could have used the word parallelogram, we could have used the word rhombus, we could have used a lot of different things here. In any type of parallelogram, the opposite sides have to be congruent. So I'm going to use those two to set them equal. I know I'm going a little faster on these, but it's kind of a repeat type of question. So, subtract off B, I'd be left with 3B. Subtract off 2, I'd have 18. Divide by 3, and we get 6. Same type of thing here. Again, these two have to be congruent. We're not worried about the other diagonal. Diagonals bisect. Those two are the two that we can set equal to each other. Subtract 2y, you get 5y. Add 11, you get 15. Divide by 5, you get 3. Alright. Now 11 is a little bit different. A square's diagonals are always, and there's more than two things that you could actually fit in here. I would say, again, like I said, there's more. Shh, guys, listen. There's more than two things you can put here. All right. I would probably say if we're just talking directly about the diagonals themselves, we would probably most likely use the words congruent and perpendicular. Oops, that's an E. But other things that you could say, that they're also bisectors, or more specifically, perpendicular bisectors. You could list a few other things there as well, but those are probably the main two, congruent and perpendicular. Number 12. For what quadrilaterals are opposite angles always congruent? Parallelograms. Now, if we say parallelogram, that means all the subcategories of parallelogram also work. So, rectangles, rhombi, and squares. For number 13, for what quadrilaterals are the diagonals always bisectors?
Parallelogram, rectangle, rhombus, and square.
Same answers, because parallelogram is where we had this, right? So since it works for a parallelogram, it works for all those subcategories of a parallelogram. Rectangles, rhombi, and squares. All right, on the back. For number 14, we have a rhombus, it says this time. If we know this is a rhombus, and they gave us the length of AE as 2x plus 6, and EC as x minus 3, says what property best explains why the equation below can be used to solve? They set those two equal to each other. So in any parallelogram, the diagonals are congruent. Oh, sorry. Did you say congruent or bisect? You said bisect each other. I wrote the wrong thing. Sorry. The diagonals. My bad. You said it right. I wrote it wrong. The diagonals bisect each other. Because if you bisect, that means you split it into two congruent parts. So these two are congruent, therefore they are equal. Right? Now, there's, again, you could have wrote this a couple different ways, because we're talking about a rhombus here, right? A rhombus is a type of parallelogram. You could have also said, in any rhombus, the diagonals bisect each other. Again, I chose to go back to the original statement of a parallelogram, because again, that's the most basic thing for this. On number 15, it wanted us to solve for angle 2. There is more than one correct way to solve for angle 2. Now, what I would look at first is this angle that's given in comparison to angle 2. Well, angle 2 is in this whole angle up here, this entire angle, and this angle down here. Those two have to be supplementary with each other. So if I did 180 minus 65, I get 115. That's this entire angle is 115. 2 is only half of that because this diagonal is bisecting that angle. So measure of angle 2 is half of the 115, which would be 57.5. Thank you. Drew a blank there. Now, that's not the only way you can solve this, right? So, can you do it the other way? What was the other way?
So, 65, since they're congruent, you put a line in the middle, and then you flip it to 65 number 1, and then you do 180 minus 65.
Yeah, because on here we have, it's actually the same exact work, but it's thinking of it in a completely different way. Because on a rhombus, all the sides are congruent, right? So the opposite angles are congruent. So we know angle 1. This is an isosceles triangle. So you could say subtract off angle 1 from 180 in a triangle, divide by 2, and you get the two base angles. It's the same exact work, just a complete different explanation, but same exact work. I don't have to change anything.
So angle 2 is when
Angle 2 by itself is just 57.5. The entire angle is 115. Angle 2 is half of that angle. All right. So anyway, there's more than one way that you can describe the work there and still get the same result. On 15, a kite. Now, the non-vertex angles of a kite have to be congruent. So these two angles are congruent. This is also 136. All four angles have to add up to what? 360. Any quadrilateral will always be 360. Because in any quadrilateral, if you were to draw in a line, you can make two triangles. Both triangles are 180 degrees, therefore the quadrilateral is 360. So, if all four have to add up to 360, I can say 360 minus 136 minus 136 minus 34 leaves us with 54.
Right, okay.
Now, oh, whoops, wait. I didn't mean to circle that. I lied. That wasn't the final answer.
Wait, what? Oh, yeah, that's
It asked for something else.
you have to add them.
It wanted us to add them. So what is x plus y?
170. I got 170.
As we got 136 plus 54 equals 190. Now, that's the way almost everybody did this problem. And I directed most of you guys in that fashion because of how you guys had started solving it. You guys had told me right away that x was equal to the 136. So then if you knew what y was, you could find it. You can add it together.
Wait, so wouldn't
There-
y be 34 though?
No, I'll go over that in just a second. So on here, there is another option. We need to know these two, right? Together. There is a much shorter way of finding
Oh,
that.
there's
All,
so there's something.
no, wait. Shh. Stop, guys. Stop guessing. On a kite, all four angles have to be 360 because in any quadrilateral they add up to 360. We know the other two. We could have just said 360 minus these two, and we'd be left with these two already added together. Does that make sense? If I subtract these two, I'm left with x and y already.
Oh, by taking it from
By subtracting off these two that we knew, I already have the 190. Again, just think about there's other ways to solve problems. You don't always have to find every single variable just because it gives you variables. All right? So, I know I've seen questions similar to that on FS8 before, where you don't really have to solve for every single variable, even though you think you might have to. So, just be careful. Now, to answer the other question that was brought up, these two are not congruent, right? The two vertex angles of a kite, in fact, they will never be congruent. Because if they were congruent, we wouldn't have a kite. We would have a parallelogram.
So what about the two?
Because if we have a quadrilateral with opposite angles congruent, it's a parallelogram. So that would change the shape.
But R is 136. X is 136, right?
X is 136. So the non-vertex angles of a kite are congruent. The vertex angles are not congruent. All right. For number 16, what's always true about a kite's diagonals? They are perpendicular. I'm just going to do perpendicular symbol. All right. How are rectangles different from rhombuses?
Rectangles don't have diagonal perpendicular.
All right, so you could have said a lot of different things here. All right. By definition, you could say rectangles have congruent angles, whereas rhombi have congruent sides. Now, there's a few people when I was going around didn't even talk about those. They talked about diagonals, and that's fine too. In a rectangle, the diagonals, so I'm going to add this fact over here. Diagonals are congruent. Rhombi diagonals are perpendicular. So again, there's more than one correct answer here. Now, on 18, how are trapezoids different from parallelograms?
Trapezoids have exactly one pair of opposite sides parallel.
All right, so there's exactly one pair of parallel sides in a trapezoid, whereas in a parallelogram, you have to have two sets. So trapezoid, one set of parallel sides. Parallelogram. Whoops, I just spelled that wrong. Parallelogram, two sets of parallel sides. On 19. What? Oh. In a parallelogram, the diagonals do not have to be congruent, only in a rectangle. All right, so in that specific type of parallelogram, a rectangle's diagonals are congruent. All right, on 19, it says that this is a rhombus. AE is 5x plus 11. EC is 2x minus 4. What equation could we have set up? 5x plus 11 plus 2x minus 4. Those two would have to be congruent. Why are they congruent? Because the diagonals bisect. Now, around here? Yeah, you can do parentheses. Yeah. All right, on 20. This one is very similar to one of the earlier ones. This was like number 15. It's the same steps, different numbers. So again, no matter which way you want to sit, you're solving it, you're going to take this angle and this angle are supplementary. So subtract the 72. You'd be left with 108 for this entire angle. And then you got to take the 108. Oops, 108. Divide by 2. And you get 54. And that's the measure of angle 2. So now, on 21, I'm going to solve this the shorter way. Because it doesn't say anywhere in there I actually have to find x and y, right? So remember, if I said x plus y plus 126 plus 39, all of that has to equal 360. So if I just subtract off those two, I already have x plus y. So subtract those two off, and you're left with 195. So again, now I'm not saying that the one that's like that on the test you don't have to find x and y. I'm just, there are questions on here that are very similar to the test. There's others that are test the same idea but not for A's in the same way. So again, it varies. There's a lot of properties. If you know your properties, it's easy. If you don't know your properties, it'll be the hardest test we've had. You got to know the properties. No, don't have to know the names. We don't have to know the names. We didn't put any proofs on it. We didn't. Again, it's for the level of difficulty. It is easy. You just have to know your properties. All right. On this next one, figure JKLM is a trapezoid. They tell us that angle J is 2x minus 3. Angle M is 5x plus 17. Which one of these equations correctly solves B? B? No, it's not B.
It says solve for x though. So
It's what? D.
Explain.
These are consecutive interior angles. Consecutive interior angles have to be supplementary. Have to add up to 180. Now, in a trapezoid, if this was an isosceles trapezoid, we know that the two base angles were equal. So like these two could have been equal, or these two could have been equal if it was an isosceles trapezoid.
how does that look again? A sausage trapezoid? How does that look?
It looks like this. It's just the fact that the two legs are congruent.
Okay.
So we don't, like most things, we can't characterize it as something particular.
It has to tell you. Yep. All right. On 23. What is the perimeter of the square below? So, does it matter which two you said equal? No. There, it's a square. All the sides should be the same. So pick the easiest two.
3x plus 2.
Subtract the 2x, you just get x. Subtract the 5, you get 3. So x is 3. We want the perimeter though, so plug it back in. 2 times 3 is 6, plus 8 is... So, all the sides are 14. So we have 4 times 14, which is 56. And then finally, on 24, MEY is 39. YEN is 5x minus 4. Together, those two form a right angle. So, 5x minus 4 plus 39 equals 90. 5x plus 35 equals 90. Subtract the 35, you get 55. Divide by 5, and you get 11. Yeah, I did that one fast because there was one similar to that already on the front, I think it was. Or maybe on the other worksheet or something. It was on the half worksheet. So, yes. Number 6. Now, so 6 was rhombi, squares, and kites. The only thing that was not represented on this worksheet, that again, you will see on the test, I would say is probably some of the stuff dealing with the coordinate plane, where you had to find like slope and things like that. Now, I will say this, all right? When you're giving coordinate points on a graph, the easiest way, and we direct you in this fashion because we ask you to show work and we ask for the slopes. The easiest way to identify a figure is based off of its slopes. Because if you identify the slope of every single side and the two diagonals, you should be able to say what type of quadrilateral it is. Because if you know, again, in a parallelogram, you're going to have the opposite sides are going to be parallel. So you should have the same slope for the opposite sides. If it was a rectangle, then your any two consecutive sides would have to be perpendicular, meaning that their slopes would have to be opposite reciprocals. In order to be a rhombus, the slopes of the diagonals, they have to be perpendicular, so they would have to be opposite reciprocals.
Are you going to say this tomorrow in class?
I am going to repeat that one time tomorrow in class.
Okay, good.
But I wanted to make sure I said it in tutoring on the recording and stuff too. Again, the slopes is the easiest way, and that's when we asked you to show work on the test, we actually asked for those different slopes.
How you were going over the thing and how you said how we know it's a square because the sides aren't all equal. But why do we have to go slopes?
Again,
We can just like look at
that would be showing work, right? So
what isn't our
could you answer the final part of the question on the test without showing work? Yes, but we are asking you to show work, and it says on the test clearly that you must show the work of finding the slope in order to actually get the full points.
Okay, so you said the rectangles, they're perpendicular. They have to be
Opposite reciprocal.
of what?
Each other. So like two consecutive sides would have to have opposite reciprocal slopes in order to be perpendicular. So that would tell you it's a rectangle. If the diagonals were opposite reciprocal slopes, then that tells you that it's a rhombus.
Do you still have your notes? We did that.
How do you know which diagonals are? How do you know which slope?
We're going to give you a diagram so that you can see where the points are. It's not going to be a hard question. So, again, as long as you can find slope and you can identify the figure, you'll be good. I'm telling you, we tried to make this test easy comparative to what we could have done. But you still have to know all your properties or it will be amazingly difficult. So,
Find the slope.
yeah, I mean, you stop this.